Let's graph this parametric equation where x is 5 sine t and y is 4 cos t, not to be confused with Ashanti, rest in peace. Whenever you graph a parametric equation, you should make a chart of t, x, y values. Now, the t's that we're going to choose, I know I'm going to choose clever ones because I'm going to eventually plug them into here and hope to take the sine and the cosine of it. So let's use all the quarters of t from 0 to pi. Maybe not even including pi. Let's just go from there. So let's start out, we're going to choose 0. We're going to choose a quarter of a pi. We're going to choose 2 quarters of a pi, so that's going to be pi over 2. We're going to choose 3 quarters of a pi, and I'm actually going to go all the way around to 2 pi because I think we should do 2 pi. I think we should do a complete circle. All right, so I'll plug in pi. I'll plug in 5 quarters of a pi. I'll plug in, what's next? 3 pi over 2. I'll plug in 7 pi over 4. And that should get me where I need to be. All right. I'm just letting you know ahead of time, I'm using a calculator for all this. So when I use these numbers, when I plug in 5 sine t, I'm plugging in 5 sine 0, which gets me 0. When I plug 5 sine pi over 4, that gets me 3.5. It gets me a much worse number than that. But again, if I'm going to just graph on here, it really doesn't matter what the exact numbers are as long as I'm graphing for accuracy. When I plug in pi over 2, I get 5 because sine of pi over 2 is 1. 5 times that is 5. When I plug this in, I get 3.5 again. When I plug in pi, I get 0 because sine of pi is 0. When I plug this in, I get negative 3.5. When I plug in 3 pi over 2, I get negative 5. And when I plug in 7 pi over 4, I get negative 3.5. So those are my x values. Okay, here, here, here. It's just everywhere. I'm going to plug these into the y function. I'm again using my calculator. I'm going to get terrible numbers and then just simplify it to, or round it rather, to the nearest tenth. When I plug in 0, I end up with 4 because cos 0 is 1. 1 times 4 is 4. When I plug in pi over 4, I end up with 2.8, which is a much worse number. But again, I'm not going to lose sleep over that. Cosine of pi over 2 is 0, so 4 times it is also 0. When I plug in 3 pi over 4, multiply it by 4, I get negative 2.8. When I plug in pi, I get negative 1. 4 times that is negative 4. When I plug this in, multiply it to 4, I get negative pi, or negative 2.8 rather. Plug in regular 3 pi over 2, I get 0. And when I plug in 7 pi over 2, I get 2.8. Gross. All right. Let's graph these. And as I graph them, I'm going to say where my t was. So 0, 4 lives around here. T was 0 for this one. 3.5 lives here-ish. 2.8 lives here-ish. And t was pi over 4 for that one. Okay, the next point is 5, 0. And that was t is pi over 2. The next point is 3.5, negative 2.8. So like right around there. That's when t was 3 pi over 4. What's the next one? 0, -4. That's when t was pi. -3.5, -3.5, right around there. -2.8, right around there. That's when t was 5 pi over 4. -5, 0, -5, 0. That's when t was 3 pi over 2. And -3.5 lives right around there. Up 2.8 lives right around there. That's when t was 7 pi over 4. So we got ourselves kind of like an oval-looking thing, an ellipse. Okay? So I'm going to try my best to draw this the best that I can. After I draw it, I'll get an oval ellipsy looking thing. And of course, we always include the directions that we go in. And again, if you're like, well, why did you stop at this number and not go to 2 pi? Because 0 is 2 pi, and why repeat myself? And as you can see, it kind of goes around in a circle. Circular, circle. What's a movie? I forget which one. I think it's Billy Madison. Like and subscribe.